30th of May, SpaceX made history by launching 2 NASA astronauts in its commercially built spacecraft to the International Space Station. After the success of NASA's Apollo moon missions, particularly the most famous one, Apollo 11, which landed the first humans on the moon, the flurry of human spaceflight plateaued. Cue eccentric tech billionaire Elon Musk. He wants to put space tourism on the map. The hope is that people replace their annual trip to Benidorm with a trip to Mars. After the first launch attempt was scrubbed on the 27th of May due to poor weather conditions, and a spectacular explosion at SpaceX's prototyping facility, the world waited with bated breath when the rocket was minutes away from launching, with a 50% certainty that Mother Nature would be merciful. And at the very last minute, Mother Nature gave her seal of approval. The Falcon 9 rocket with the Crew Dragon capsule fixed on top, carrying Bob Behnken and Douglas Hurley, lifted off at 8:22 p.m. at NASA's Kennedy Space Center in Florida. This Demo 2 test flight marks the first all-but-a-human spaceflight to depart from American soil since NASA's final space shuttle launch in 2011. The Demo 1 test flight last year only had a dummy on board. Demo 2 was particularly nail-biting because SpaceX had to prove that Crew Dragon could deliver with humans on board. The test flight marks the start of a beautiful friendship between NASA and SpaceX. The success of this test flight mission will pave the way for regular flights with Crew Dragon to the ISS and beyond. Crew Dragon set off to soar across the Atlantic. After 2.5 minutes, the rocket had separated to return to a drone ship at sea. After a further 6 minutes, the Crew Dragon capsule safely slipped into the Earth's orbit. With 19 hours to kill, Behnken and Hurley named their capsule Endeavour. Endeavour successfully docked automatically this time on the ISS around 3:29 p.m. After a wait for leak, pressure and checks, the pair joined 1 American and 2 Russian crewmates already on board. Although the duo is trained primarily to test Crew Dragon, it will be parked for the duration of their stay, which could be up to 4 months, as they help with station operations. Upon arrival back on Earth, safely, hopefully, 4 parachutes on the Crew Dragon will help lower the crew gently down into the Atlantic, where they'll be recovered by a SpaceX vessel. So what does this historic launch mean for ordinary people like you and me? Why does it matter? Well, I spoke to Dr Matteo Ceriotti of the University of Glasgow to find out.
So I want to know, what is the International Space Station and what is its purpose?
Yeah, so the space station is a science laboratory in space, essentially. It's just a big laboratory for a space environment. Space environment is very different from the Earth environment in several ways. So there is, first of all, microgravity, so extremely low gravity in space, extreme temperatures, and I'm not just talking about cold temperatures, but also high temperatures. High vacuum, there is no pressure, no air in space, and intense radiation coming both from the sun and from the outer solar system. So these are the space, the effects of the space environment. And the space station is a laboratory for a range of experiments in a whole wide set of fields: astrobiology, astronomy, meteorology, physics, space medicine, biology, life sciences in general, and also to test future spacecraft components. It's a giant station at the moment. The mass is 420 tons, so 420,000 kilograms.
And wow, that's incredible. I didn't know it was that large and heavy.
73 meters long and 109 meters wide. So it's extremely, extremely large. But it was built little by little, component after component. So the first component was launched in 1998 and has been occupied with a crew continuously for more than 19 years now, through 63 different expeditions of astronauts. We had 241 astronauts from 20 different countries in the space station.
Wow.
The advantage of using a large space station with a crew on it, with respect to using satellites to perform similar experiments, is that the experiments can be long, can be performed potentially for decades, and there is already access with a human researcher up there that can send the data on the experiment back on Earth to scientists on Earth, and scientists on Earth can analyze the data and provide immediate feedback to the astronaut, which can then tweak the experiment. And this is certainly not possible if we were to send an automatic satellite, where the experiment is designed and built on Earth and then sent into space. Then there is no way to change that experiment anymore, should a change be needed.
So how expensive is it to launch a rocket, with or without a crew? And how can we make space tourism relatively affordable?
Yeah. So I've done a little bit of research, and I can give you a few numbers. The costs are varying considerably depending on the type of launch and depending on where you're launching to. But let's keep as a reference a low Earth orbit, so kind of the orbit immediately around the Earth where the space station is. So if we were to take the NASA space shuttle, which is not operational anymore, but has been used for a number of years to access the space station. So for launching payload, so not a crew, but a payload, the cost of the space shuttle was $54,000 per kilogram. Okay. If this has been lowered considerably over the years, particularly by SpaceX with, say, the last rocket they have, the Falcon 9. So with the Falcon 9, we can access low Earth orbit with the satellite for only $2,700 per kilogram. So this is a factor of 20 in between the space shuttle and Falcon 9.
Yeah,
for crewed launches, for launching a crew into the space station, things are a little bit more expensive because you need additional equipment to carry the crew, right? And so for the space shuttle, the cost goes up to 93,000 kilograms per dollars per kilogram. For Falcon 9, with the Dragon capsule is the one that is carrying the astronauts that mounts on top of the Falcon 9 rocket, then the cost is $23,000 per kilogram. So again, we have a reduction of a factor of 4 using the Falcon 9 with respect to the old space shuttle. And this is all the cost saving that NASA now can afford by using SpaceX to access the space station as opposed to use the space shuttle as they were used to do before. So how do we get to reduce the cost for accessing to space? Well, SpaceX has been able to reduce the cost with some technological advances, some tweaks to the technology that goes into the rockets, but most importantly has been reusability of components. If you've seen the launch of Falcon 9, then you could also see that Falcon 9 after launch and after delivering the payload to orbit is able to reignite the rockets again and come down and perform what's called a soft landing. So in a soft landing, effectively, the entire rocket lands and is reusable for the following launch, of course, after checking the crucial components. And this was something that wasn't happening with the space shuttle. With the space shuttle, components were coming down with a parachute in the ocean. So you can imagine that something falls in the ocean with a parachute. Can be partly recovered, but not completely. So reusability is key for reducing the cost of launches of space exploration. But there are also other things that can be done. One is the economy of scale, of course. So the more launches we get, the lower the cost of the launches will be. And so SpaceX has been able to exploit commercial launches, so to launch payloads from other companies and even other countries, so not only the US, into space, in order to get the money enough to keep the launches going and therefore reduce the cost of each single launch. Another trend in current space exploration is the reduction of mass and volume, so going small instead of going large. So launching multiple spacecraft of small size, and also standardization of components, so building spacecraft that can fit in a certain standard. Therefore, rockets do not need to be designed specifically for that spacecraft. And one example is CubeSat. CubeSat is a standard of spacecraft that is 10 by 10 by 10 centimeters, and they can be easily stacked one on top of the other to be launched all together.
Brilliant.
Other
like
things,
Legos.
probably a little bit farther future is in-orbit assembly and in-orbit manufacturing. So if we were able to not just send a ready-made spacecraft in space, but we could send a 3D printer in space, then the 3D printer would be able to 3D print components of spacecraft directly there, and this would be a huge cost saving. where does the 3D printer find the material to print? Well, the raw material could be, in the first instance, launched again from Earth, but this is still expensive.
Yeah.
But in the far future, we may be able to extract the material, say, from the moon, or extract the material from a nearby asteroid. So if we could use the material from the asteroid, then we have the metals and we have the water that are needed to 3D print structures, and therefore the cost would essentially be near zero, because there is
Wow,
nothing
that's
that is
incredible.
launched from the Earth.
Although we know that the SpaceX launch was an incredible American achievement, can we both agree that the success of space travel hinges on the cooperation and collaborations with international space agencies and aerospace companies?
The International Space Station itself is a joint collaboration from different space agencies. So there is NASA from the United States, there is Roscosmos, which is the Russian agency, JAXA, the Japanese agency, ESA, the European Space Agency, and CSA, which is the Canadian Space Agency. So already just for the space station, we have 5 large nations that are collaborating. Not just these nations are involved, in the sense that astronauts from other nations were able to access the space station as well. The story of the Apollo 13 rescue. So Apollo 13 was the mission that was supposed to go to the moon, but then faulty oxygen tank, which endangered the life of the astronauts. But the astronauts were ultimately able to come back to the Earth.
Yeah, but that's the furthest I think we've traveled.
Yes. Yeah, so when they came back to Earth, because of all the issues they had during the mission, they weren't quite sure where they were going to land on Earth. So they could have landed in a place where they could have been rescued by the American boats, but also in a place that was very far. And the USSR at that time offered to help with rescuing the astronauts should they land in a territory where they could help. And this was extremely important, because at that time, the USSR was in a very tough competition with the US for the race of the moon, and time of the Cold War and so on. So it was quite sensational that they offered this kind of help. And so this was an example of completely unintentional, if you want, international collaboration between 2 different institutions.
We've had dogs, chimps, frogs, bacteria, amoeba, all sorts of things travel to space. So when can we expect the average Joe to travel to space, and how soon can we expect space tourism to take flight?
We had space tourists already, a handful of them. So Ed Dennis Tito was the first one, was an American millionaire. He spent 8 days in the space station orbiting as a crew member. But from 2001 to 2009, there were 7 space tourists who accessed the space station using the Soyuz Russian launcher. It's estimated, we're not completely sure, but it's estimated that they spent $20 million for each one of their visits. So it was possible to visit the space station. It's not possible anymore, because now the space station is fully used by crew for experiments. But at that time, if you had the money, then you could visit the space station. So we did have a little bit of space tourism. The issue is that, first of all, it's very expensive, as you may guess.
Yeah.
And, the reason why it's expensive is connected with the expenses of launch and dealing with people in space, with astronauts in space. So again, the economy of scale is what we need to make it more affordable. Of course, it's a little bit of chicken and egg problem, because if it's so expensive, not so many people will be eager to put their money on it, right? or can afford it at all. But at the same time, if there is no demand, then there is it's difficult to lower
There's no
the
supply.
cost. Yeah, but there are other things. So going to space at the moment, it's a little bit harder than taking a plane, for example. There is a number of skills that are required in order to fly on a rocket onto a space station. So if you think about spacesuits, you need to be able to wear a spacesuit, you need to be able to use a spacesuit and do basic tasks in weightlessness. So once you're up there is no gravity. You need to relearn all these things, and you need to be trained for it. It's not something that you can learn once you're up there. there is the whole issue of the space environment that's very different, as we were saying, not just microgravity, but potentially extreme temperatures and protection from radiation and so on. And then astronauts need to be prepared for contingencies. So, you know, when you board the plane, you're told if there is an emergency, where is the life vest, and so on. So this is sort of a very brief introduction that every passenger has to go through to know what to do in the case of an emergency. Now, in space, all this thing is like multiplied a billion times. There are
so many things that can go wrong.
Can potentially go wrong, and astronauts need to be prepared for most of them, all of them. Right? So this is why astronauts go through a training process that literally lasts tens of years, and there is very little that we can do around it with the current technology that we have for going to space. The other thing is the physical training that is required. So nutrition in space is very different. They use mostly rehydrated food, so it's something that the body needs to be used to. There is psychological training as well, because of course you're going to be there for days, maybe weeks, in a very, very confined environment with a number of people doing difficult tasks. So it's quite challenging mentally as well. And the fitness that is needed. So unfortunately, at the moment, not everyone would be able to fly a rocket, because rocket experiences very high levels of acceleration at launch. We're talking about 7, 8 Gs. So this is something that is squishing your body against the seat quite strongly, and there are very hard vibrations. And you literally need to physically be very healthy and very fit to withstand this sort of pressure on your body.
So would they then have to select the type of person who can fly into space?
So astronaut selection is a very, very tough process, yes. So they select a handful of astronauts out of thousands of applicants.
And that also includes the wealthy. Yeah. So money can't sort of evade the fact that you still need to physically, mentally, emotionally invest into traveling into space. So that's interesting. That's interesting to know.
Something relatively more affordable is suborbital space tourism. So suborbital flight is a flight that essentially follows a parabola, but then it doesn't go into a full orbit around the Earth, but it comes back onto the Earth before the full orbit is concluded. So this is something that has been more affordable, in the sense that if we look, for example, at Virgin Galactic has been selling tickets for a price of $200,000, which is still extremely expensive, but it's much more affordable than the thanks of me talking before. And Virgin Galactic is a private company, so this is much more affordable in terms of the economy of it. And they managed to sell about 700 tickets. Unfortunately, they had an event, I think in 2014, where one of their spaceships broke up during a test flight. And this was a bit of a setback in the progress of developing their plan for space tourism. But I think we are going to get there. A suborbital flight only lasts a few minutes, but it gives you the experience of weightlessness for a while, and it lets people see the curvature of the Earth above the clouds and so on. So it's very different than staying 10 days in orbit, but it's much more affordable even by private companies.
Not to rip on any of your achievements, I've had some young students come up to me and say, this is all great, you know, traveling into space, populating the cosmos, but what's the point? There are so many issues happening here on Earth as we speak, from climate change to poverty to even systemic racism. Why can't we focus our efforts on dealing with the issues here on Earth, rather than trying to build ecosystems from dead rock?
So there are several reasons to still explore space, despite putting our efforts on other things that are extremely important as well. So the first one I would say is just the desire to explore and to challenge our boundaries in the scientific knowledge. This is the very first driver for space exploration. But then also understanding the solar system, understanding where life came from, and where the Earth is coming from, how the solar system originated, and so on. We also want to be able to demonstrate that we can live outside of the planet Earth for extended amounts of time, and that's one of the purposes of the International Space Station. If in the future we will ever need to leave our planet or settle to another planet, then we need to be prepared for that. And the final reason is that in space research, it's like any type of fundamental science research. We don't really know what the outcome is going to be. We need to do it because there might be something good coming out that we still don't know, but there may be. And history says that this is actually the case for most of the fundamental science. But aside from this, there is a whole number of services that space exploration has been able to provide back on Earth. And one of the things is that space is sort of infused in our society, but it's very difficult to see it, right? It's not tangible, right? Some examples of space services that we use on a daily basis. Well, first one is probably navigation. Now we heavily rely on navigation on our mobile phone, maps, tracking for exercise and so on. But navigation is possible because we have satellites orbiting around the Earth, GPS, GLONASS, Galileo, the European Galileo, and so on. Telecommunications, satellite TV, satellite phones, internet in remote areas is enabled by satellite internet, where we cannot drag literally a cable to every household. Satellite internet is actually available. Weather forecasts, so we're able to predict the weather so well because of satellite imagery. And then a whole set of mapping, so mapping the sea, mapping land and ice, and mapping the altitude and the depth of mountains and seas, subsidence of Earth, vegetation, forests, mapping the change of the forests. So you mentioned climate change. We can track climate change from space very well. So we can track how the ice pack in the North Pole is shrinking because of climate change, how the forests are being used or misused from space. We can track ships as well, the quality of the air pollution, telemedicine, and so on. So a whole set of services are coming from space and are enabled by space exploration. There is a very long list of items that have actually originated from space that we use every day. Some of them are just camera phones, LEDs, water purification systems, dust buster, and so on. So these are very mundane items that we use every day. From space. The other misconception that I wanted to point out is that space is actually relatively cheap with respect to other things. So I've looked into the numbers a little bit, and the NASA budget in the US for the moment is roughly 0.4% of the total plans to spend, 0.4%. So this is about $18 billion. So it sounds a lot if you say $18 billion, but put into context, it's a very, very small fraction. So other things that are more expensive than the NASA budget, the entire NASA budget. So it's the whole spend of the US on pizzas. This is $27 billion. The American population is spending $27 billion on pizza, which is fair enough. I also like pizza very much.
Right.
There are other things that are a little bit more questionable. $97 billion on alcohol.
Poisoning yourself, that's great, money well spent.
And $500 billion on gambling. So 10 times.
Wow.
More than 10 times. 50 times more is spent on gambling than on space activities in the US. Is space expensive? I would say no.
Well, that was out of this world. Don't forget to like, comment and subscribe. I love you to the moon and back, and I'll see you in the next video.